Hey, I wish I could be in New York, but thanks to the Google Maps because it offers a wonderful feature, Street View. As you can see, using the Street View, we are able to move and move around from street to another street, which is great. So today we are going to use Python in New York. We are going to implement a real-time object detection, which is able to move simultaneously along with its detection. So our main purpose is to write a robot which starts from this place right behind the McDonald's, and after reaching to the 7th Avenue, it moves towards Times Square, which is a beautiful street, as you can see, and as you know, it's a famous one in New York. And also we detect object simultaneously and move. So it's a great project. And in this project, I'm going to use many useful libraries in Python. We are going to use YOLO version 8, which is powerful and fast enough to make this happen. And you will learn how to use threading. I will use two main threads in this project. The first thread is for detecting object using YOLO and capturing the screen using PyWin32, which here I have implemented the fastest method to capture a screenshot on our screen. So another thread is for our movement. Our bot, as I said before, sometimes prefer to move to the right, move to the left. Sometimes it moves around and detects objects. So I have used many different things, and we are going to run and make everything prepared step by step. I'm Amir, and you're watching CodeMate TV. Let's make this done. So let's get started. As you can see, I have divided my code into three parts for you guys to understand it better. And I want to start by capture.py because we want to capture the data from our screen. I mean a screenshot that we normally take as fast as possible. And by researching and Googling, I found that PyWin32 plays an important role for us because it is fast enough. So I first called getWindow function from PyWin32 GUI. You can install all the PyWin32 packages by using using this command, just PyWin32. It automatically installs all the necessary libraries. So yeah, I first got the Excel window and then I changed it into bitmap, and then I just created a NumPy array from the buffer that PyWin32 gives us. I found many necessary things from its documentation, and also I have Googled a lot for finding this capture method, and I put the documentation here, so you can check it out if you want. Then it is, I have to say that it is really necessary to remove the alpha channel and also reshape our image, as you can see, because otherwise OpenCV gives error. So then I just release and delete the data, unnecessary data. So then I have implemented the function named test, as you can see, in a loop by using imshow. It just call get a screenshot that we implemented here and just show the whole desktop. So first run the capture.py. So I just first created an object, then just call the test function. As you can see, we are capturing a screenshot as fast as possible. It is really important because we don't want to lose data on performance in this code. So now we have the required data. As you can see, we can capture whole screen, but the problem is at the moment I don't have another screen, a monitor, so I decided to divide my screen into two parts, and I just want to capture the left side of my screen, but I'm not sure about the coordinates and the size. So by looking in Stack Overflow and Google, I found that we can here change it and crop the data that we take from our screen, and I just wanted to show how we can take a complete screenshot from our screen. So I just want to set these values, and I will show you how you can take your custom coordinates for the area that you want when you capture, takes a screenshot from. And so just let me rerun this script. So we just, this line, I remove and take images based on the values that I gave here, left and top and width and height. But the previous attempt was, the values for left and top was 0, and it was 90/20 as I said before, and 1080. So now we just change it into this. So now, as you can see, I just take the left side. It's not the left side, it's just the exact coordinate that I specified in this area. And in this line, I just crop and change the data on our screen. So now I'm going to show you how you can take the coordinates that you want for your custom project. So that's why I have implemented get coordinates function here. As you can see, it uses PyAuto GUI. You can simply install it by using this command, PyAuto GUI. So you just wait 8 seconds for you to prepare the screen, and then you have to take a screenshot by using snipping tools, and then by locate on a screen it returns the coordinates. That's it. So for example, we want to take the coordinates of only this area. Maybe it's quite small, but let's see what happens. So then we need to save the file somewhere in our PC. I just want to save it as capture.png. So because it's a static method, you don't need to first create an object then call it. We can simply call it immediately. So now I just want to rerun the capture.py. It gives us 8 seconds to prepare the screen. So then it immediately returns the coordinates. So let's see what happens. So as you can see, we have left, top, width and height based on the image that we took. So you just have to simply change the value. Just let me comment these lines and then change the values based on 18 for left, 160 for tall, 63 actually. It was really small. I hope it works. I haven't took something like this before. So now our capture.py just capture that area that we specified. So let's see what happens. Oh, my bad. I just have to comment these lines and comment out these lines again. So as you can see, we just have this area, which is good. Look, and it just gives us the area that we specified before. So from now on, we have a capture functions to capture screenshots. So just let me make it minimized. So now we have this area. So, but because it is small, I just want to make something different. I mean, I just want to clear our screen by removing elements that are available on our URL page. I mean, in Google Maps. So we just want to delete element to make it more clear. So and also this line by removing this, and also this one, and the last one actually. So that's enough. So let's move on to the movement part. I mean work.py. As you can see, I have mainly used Piotr GUI for this responsibility and PyWin32. Piotr GUI just for using its hotkey by pressing the up arrow only one time. I mean pressing just pressing for a second, and for holding a keyboard, I mean for holding an arrow, I use PyWin32 because it worked better in my project. So it depends on you and your project. So just let me explain how Street View works. You can simply press the up arrow to move to the forward. As you can see, by pressing the up arrow, you can move to the forward, and conversely, by pressing the down arrow, you can come back. I mean, you can move to the backward. So for this purpose, I simply implemented a function move forward. It takes steps and waiting times for its arguments. I implemented a for loop, and then by calling hotkey from Piotr GUI, it simply press the up arrow for us, and then it waits for the time that we want. For example, in the run function, which is the main function in this script, I said that move forward, and I gave 2 and 4 for the argument. It means you have to press, I mean you have to go to the forward 2 times, and also in each step you have to wait 4 seconds. I used this waiting time here because I wanted to download everything on my URL, I mean on my screen on Street View, because when you move fast, some images can't be loaded, as you just saw. So I just wanted our bot to wait for something like 4 seconds or maybe 5 seconds. So now it's time for move around function, because we want our bot to perform something like turning to the right and also turning to the left. And I just did this job by implementing a function named movement. It takes direction and seconds. I used PyWin32 because it worked better in my project when it comes to holding a key. I was not able to do it using Piotr GUI. That's why I just used PyWin32 to hold a key. I mean to hold an arrow. For example, right arrow or maybe left arrow. So it's not like a move forward function. We cannot turn to the left by pressing 1 time. So that's why we need to hold the left arrow for a specific seconds, for example 4 seconds or maybe 3 seconds. So that's it's the job of this function, I mean movement, and by taking the current time, it starts a loop, and when the time passes, it breaks. I mean it is broken by itself, and then release the key, I mean call the key up, as you can see here. So it's for our movement, and yeah, and it is only turns to the left and right by this key code that I found from win32.com, vk right or maybe vk left for the left and right arrows. So yeah, that's it. It's not a big deal. And for moving around, I just decided to first go to the left side and then turn back to the right side and then move to the right side and then move to the left side. And all seconds are similar as we pass to it as an argument in move around. For example, here we have a move around function for 1 second. It means that when we are here at this location, we first for 1 second move to the left side, like something like this, and then we go to the right for 1 second again, then again for right, and then again for left. I just try to make something like moving around, as you just saw. So and the main function that we have is a run, and first we just click on the screen, but when you just click, I mean when you just press the left click, it goes to that destination, something like move forward. But you can, for example, click on this side, it's not just moving to the next step, it can jump from one step to another step. For example, it can jump into another street by simply clicking on that area. And I wanted to press and the bottom is right, because when you just click, I mean when you just right click on a screen, it just, I mean we can simply activate it, because when we are here, when we press the left button, it just left to the for example, as you can see my cursor, so it doesn't work. So I just wanted to activate the screen by simply clicking to the right button. So as you can see, I first right click on a screen, and then I can, I mean move to the left or right, or maybe move to the forward. Then first, so our job is to, as you can see in run function, is to first click to this area, then move forward, as you can see 2 times, and between each times you have to, I mean our bot needs to wait 4 seconds, and 1 move forward, then sleep, I mean waiting time for 3 seconds, move forward, move around for 1.5, for example 1.5 something for left, 1.5 for right, 1.5 for right again, and it comes back to its main location, I mean its original location. So that's it. I just wanted to make our real-time object detection a little bit fascinating by doing some automated movement. So just let me run the walk.py and see what's happening. Before running, I need to tell you that when we want to automate some specific movement or job, for example moving to the exact location from B to C and from C to D, we always need to be at the same place when we want to start. So that's why I have decided to start always from this location whenever we want to run our project, because for example sometimes we need to move to the left or maybe right, but there is no left or right option because we are behind the wall maybe. So it's okay to start always from something that we know. That's why I just created a start point, and whenever we run our bot, it tends to start from right here. So just let me remove these areas again. Let's see how it works. Let me change my directory, and also we need to call run function here as a main function. So it simply click immediately on this screen to make it activated, and it's a right click instead of left one. As I said before, something different happens if we click, if we left click on a screen, and I just took these values randomly, because no matter where we click using pio2gui.position. So I have a wonderful playlist teaching and talking about pio2gui OpenCV object detection tips. You can find the link in the description. So now it's time to run this movement. Okay. First right click, make it activated, move forward, and wait 4 seconds. As we said before, it's moving around the function. Again, move forward if I'm not mistaken, 3 times, and 4 seconds for waiting time. So moving to the left, then click to that area. So everything sounds okay. So I have a problem in my internet connection. That's why I'm using waiting time a little bit, too much. That's why I'm using waiting time too much. So yeah, everything sounds okay, no problems. And I think it's time to jump into the object detection. So I think after a moving around, it's going to be a last step, moving around for 2 seconds. So okay, now we have our movement function. Also we have a window capture function which is able to take screenshots as fast as possible based on these coordinates. I think we need to change it again to the default version that I first took for this area. It should be a little bit smaller, I think. And it's time to talk about our object detection, YOLO. I have used Ultralytics for our YOLO model, and for installing Ultralytics I put the documentation about its installation here. You can simply click on it, so you can install it using pip, and it automatically installs all necessary libraries such as NumPy maybe, for example, and many more. There are many things that you need to install for running your YOLO, and also you can use this command and take the package from GitHub. And also apart from installing Ultralytics, you have to install Coda for the PyTorch. So you can use this link, and you can install the latest version using pip, and I have installed all the necessary libraries, so you have to do it on your own. And apart from the installing Coda for your PyTorch, you have to also install toolkit, Coda toolkit, which is for NVIDIA. So I also put the link here, and that's it. Apart from Ultralytics, I've used OpenCV time for waiting time, and also I have called run function as I implemented in my work.py, and I just imported it. And same for window capture, I imported it from capture.py. So also I have used threading because we are not able to take screenshots and detect objects, and also move because we are not able to move, and we need to create another thread to do a new process. That's why I use threading. We are close to final results, just we need to import our model. We just have to use the capital YOLO that we imported from Ultralytics and use the model that we need for our own projects. In this project, I wanted to detect more objects, so the model that I wanted to use needed to have more labels or more pre-trained classes. That's why I used a model which is trained on image version 7, which is for Google. So you can select your own model, which are trained based on Cuckoo datasets, if I'm not mistaken. Ultralytics offers many models from YOLO version 1 to YOLO version 9, but I decided to use this one. And by running this code, it automatically downloads the pre-trained weight, so you can simply use it, but also you can download it manually from their websites. Just follow this link that I put. And another factor which is important, many of you may want to run this project on your CPU because you do not have definitely you don't have a GPU or graphic card. So it's fine, it's okay, it can be run on your CPU, but I have a suggestion for you. You can first export and convert your model into ONNX format instead of PT PyTorch, because it runs 3 times faster when you want to run it on your CPU. And by only simply using this command in your code, you can convert your PyTorch models into ONNX, and then instead of using .pt, you just have to use this one when you want to run the code on your CPU. So before jumping into the final results, having our real-time object detections and movement ability, I just want to show you how our real-time object detection works. So I simply first created an object from window capture that I called right here, and then I call the screenshot method that we implemented here, and we just simply predicted the model. We just predicted the results based on the image that we take using our window capture. And I take this part, it gives us the annotated frame, it has the results, and it is already plotted, and I can simply show it using cv2.imshow, maybe, I'm not sure about this. So yeah, Ultralytics have many examples. You just have to check their websites. For example, I took this line from their examples, and that's it. Let's run the YOLO model. Just let me check everything is okay. Okay. So, that's it. It is exactly what I wanted. I wanted a model which is able to detect billboards and also skyscrapers, as you can see, because in version 9, Ultralytics do not have a pre-trained models based on the version 7 of that dataset that I was talking about. So I just decided to use version 8. So as you can see, it is able to detect objects as fast as possible thanks to our window capture functions, because it's really important without any lag and delay. So okay, everything sounds okay. Let's move to the next part. So now it's time to move to the final part, to use threading. I just imported thread from threading, and I decided to create 2 threads because, as I said before, we are not able to run these 2 jobs together. So we have to separate the threads and run both of them simultaneously. So I dedicated object for our real-time object detection for first thread T1, and our movement function for in T2. So we just first need to remove this OBB. If you're not familiar with threadings in Python, you just have to simply follow this link. It has some simple examples which are really helpful. So first we run the first thread, I mean our object detection. Then we need to wait 10 seconds to prepare everything. Then we need to move because it is not able to run immediately. As you saw, it takes something like 5 or 6 seconds. So I just decided to give it 10 seconds for the waiting time. Then I immediately start the second thread, which is our movement. Then at the end, I just join threads together when they are done. So you have to use join method when you are using multiple threads. Yeah, just follow this link. It is really helpful. Be careful to start from the location that our robot knows its path, maybe. So you just have to start from the point that we set all the steps here, because we don't want to move and walk randomly. So as I said before, yeah, I have explained everything before. So just let me remove these parts again. So it should runs our real-time object detection. Then it waits for 10 seconds. As you can see, everything sounds okay. And after waiting for 10 seconds, it will start its movement function as we implemented. After this street, and after reaching to 7th Avenue, it moves to the Times Square. So let's see, it finds its path. Moving around here, detecting object simultaneously as we implemented. So it moving toward Times Square as we said to it. Hope you enjoyed this video. Don't forget to like it if you learned something new, and I'd like to see you in the next video.